Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 1123, lowest common ancestor of deepest leaves. This problem is based out of binary tree and it has been asked in Meta and Amazon. Also, this question is similar to problem 865 on LeetCode. So both the problem statements are completely same. So if you are done with this, you can submit both the problems and it's marked as medium. Let's have a look on the problem statement. In the problem, we are given root of a binary tree and what we have to return is lowest common ancestor of deepest leaves. So this is our complete problem statement. See, finding lowest common ancestor of given two nodes A and B. This is a pretty standard problem in arrays. If you have not solved it yet, go check it out and try to submit it. Okay, what else? This is just definition of what is a leaf, what is the depth of the binary tree, and what is lowest common ancestor. So I'll just explain it to you while solving the problem statement. In the constraint, what they are saying, all the nodes are unique. Node value will go till 1000 and number of nodes will also be in this range 1 to 1000. This is the second problem 865. Smallest subtree such that it contains all the deepest nodes is the same thing. This is the same thing, finding the lowest common ancestor LCA of the deepest node leaves. Okay, now let's come to the problem statement. Here, this is the binary tree given to us, and here what we have to return is lowest common ancestor of leaf node with maximum depth. Lowest common ancestor of deepest leaves. Okay, here in this problem, what are the leaf nodes? 1, 2, 3, 4, 5. And what are the leaves on the deepest level? Only these two. What is the least common ancestor of these two leaf nodes? See, in this case, 2, 5 and 3. These are their ancestors. 2 is the parent of parent, parent of parent of parent. These three are the ancestors, and here among these three ancestors, what is the deepest one? Deepest one is 2. So from this problem statement we have to return 2. Now this is our complete problem statement and you just have to return the root of 2. I hope you understood the problem statement. Then finding the lowest common ancestor of leaves on the lowest level. In this case, we are not given specific number of nodes. They just want us to find the root such that all the leaf nodes on the lowest level will be the part of this subtree starting with 2. Okay, so here just try to analyze how we can solve this problem statement. See, let me give you a situation. Let's say there is one node here with value 11. In this case, what is the lowest common ancestor of deepest leaves? That would be 3. Why? Because 7, 4, 11. We have 3 leaves now. And both of these 3 leaves share a common ancestor which is 3. Why 3? Because one node is on the right side of the tree and one node is on the left side of the tree. But if I remove 11, let me remove 11 now. As soon as I remove 11, what happened? The answer shift from 3 to 2. From 3 it shift to 2. Why? Because all the deepest leaves are on the left subtree now. All the deepest leaves are on the left subtree. Still, in this problem, 5 is not the answer. The answer is 2. Let's do the similar kind of situation here. If at this I add a node 11. In this case 5 will become the answer. Why? Because there is at least one deepest leaf on the left side, at least one deepest leaf on the right side. This is the left subtree, right subtree, and the height of the left subtree and the height of the right subtree is same, which means one of the deepest leaf will be on the left side, at least one of the leaf on the right side. So in this case I will just return 5. In the previous case I was returning 3. Now if you just skip the 11 part, in this case what node I should return? I am returning 2. Why? Because the left subtree height is equal to right subtree height. This equation shows that at least one deepest node is on the left side of the tree, at least one deepest node is on the right part of the subtree. So whatever is the left and the right part, the root is always the common part. So this equation, this property that the root is common among the left part and the right part will be using while solving the problem statement, and we'll be considering root if the left subtree height is equal to the right subtree height. But if it is not the case, let's say for 3 the left subtree height is equal to 3 and the right subtree height is equal to 2, both are not same, it means that whatever is the deepest subtree, I will be searching that. So in this case go to the left part, right? Otherwise just return the root. Okay, so what the idea that I'm getting is that whatever the solution function I have to write with the root, and then tree node is something I have to return. What is our edge case? If let's say given root is null, or in this case I'm just going to the left part of any leaf, let's say going to this left part. In this case if it is null, just return null. Root is equal to null. If root is null, return root or return null. Otherwise what we are going to do is we will be going to capture these two property, left height and the right height. Let's say height is another utility function, root dot left, height root dot. Now we have left height and right height. If both the heights are same, it means whatever is the current root, that is going to be my answer. Return root. Otherwise I need to make a nested call of solution function. If left height is greater than right height, then what I have to return is solution of root dot left. It means solution will definitely be lying on the left part. Otherwise return solution of right dot right. Otherwise go to the right side. Now if I just directly show you, this is my base case if the root is null. Otherwise calculate the left height, calculate the right height. How I can calculate the height? We'll write a function for that. If both the heights are same, it means that root is the common part, least common ancestor, and if they are having the same height, it means at least one deepest leaf will be on the left side or right side. Otherwise if left height is greater, it means deepest leaf will only lie on the left part. Otherwise deepest leaf will only lie on the right part. Simple. So this is something we have to do. And what is this height function? See, height function is the height of the tree. We are taking parameter as root. What is this height? If the firstly let's take care of the corner case, edge case. If root is equal to null, if root is null, height is 0. Otherwise what is the height? whatever is the maximum height from the left part or the right part, height of left, height of right, whatever portion is taller, having a larger height or larger depth, take that plus 1. So this is something I have to return. This is my height function. So in this case, if I just take the same example, let me take copy and paste. In this case, what is the height of the tree with a root equal to 3? Whatever is the maximum height. For the left subtree, the height is 2. For the right subtree, the height is 1. Number of edges, just count the number of edges. 1, 2. Here is this 1. So whatever is the maximum, 2 or 1, just take that. Maximum value is 2 plus 1. Why 1? Because this edge we are including. And this is the height. So 3 is the height of the deepest leaf. Okay. Now what is the time and space complexity? Time complexity is, see, solution function will be going like, it is firstly calculating the height of the left subtree, height of the right subtree. It means it is calculating the height of the whole tree, and calculating the height will go till order of n time. And once we have calculated the height, then we are comparing the value and skipping one part, skipping either the right part or the left part. So that complexity is log of n. So in total, this approach is going order of log n into n. But here in this case, this n will not always be the n, because firstly we are calculating the height with the root, and then we are calculating height with the root dot left or root dot right. So it will be, let's say, half every time. So in total, I think it should be going around order of n time complexity. But yeah, we can do better by skipping the height subcall or height utility function by just returning 2 parameters out of our solution call. But don't worry about that, we'll just do like this. And after that, you can check the lowest common ancestor of any 2 nodes. You'll get the idea. Now let's code this approach. First of all, lowest common ancestor of deepest leaves. If the root is null. If the root is null, what we can return? We have to return null. Otherwise, I will be calculating left height and the right height. How can I calculate the height? Left height, I will be calculating root dot left, and the right height, I will be calculating root dot right. See, now we have to decide. If both the heights are same, it means the deepest leaves are distributed among left and the right side. If it is distributed among left and right side, there is no other option than the root, because root is the nearest one, nearest ancestor. If left height is equal to right height, then return root. If left height is greater than the right height, then call the same function. Calling the same function, but in this case, root is of no use, right subtree is of no use. Only the left subtree will give me the answer. So root dot left. Otherwise, root dot right. And we have only 3 possibilities. Either the root is the answer, or answer is on left side, answer is on the right side. So we have to return from here. Return this. So now my program is done. And what is this height? And now we have to write the height function. Height function is going to give me the height of whatever root we are passing. Private int height, and it is going to take parameter as a root. What is the edge case here? If root is equal to null, any left or right subtree of any leaf, in that case the height is 0. Otherwise, what is the height? if the root is not null, then definitely root should be considered plus any of the left subtree or right subtree. If I am considering left subtree, then I will be taking the height of the left subtree. So math.max, whatever is the value of, let's say, height of root.left or height of root.right. So if the root is null, 0, otherwise consider root, and whatever is the bigger largest subtree, bigger subtree, just take that. Now let me test our sample test cases. Sample test cases are passed. I'm submitting the problem. It's submitted successfully and 100% faster. I hope you understood the approach. Thank you guys. Bye bye. In case you want to explore better, or if you just have a look on the editorial, this problem is something they are just doing it in a single traversal. So if you are okay with that, if you are able to understand that, just go with that. Otherwise, just to keep it simple, this is a good solution. Thank you guys. Bye bye.